My name is Remy Pangle. I'm with the Center for the Advancement of Sustainable Energy here at JMU. I'm going to be talking to you about how we can take our solar circuits and diagram them so that you have them on paper and for submission when you're doing a solar challenge. It is important to be able to take a solar circuit and interpret it on paper because in the challenge, the idea is that you shouldn't be able to see the wires. So this is a very important piece of the competition. We're going to go through some basic circuits. We'll get a little bit more complex in the circuits. The one thing we will not cover is how to build a solar circuit diagram that incorporates a microcontroller. If you are in need of that sort of assistance, let us know and we can connect you with folks at KidWind who are able to help you with that. I do want to refer you to the solar circuit diagram sheet that you can access in the KidWind website and also on our website. This is where the team will fill out their name and the school name, and then there is a box for you to hand draw your solar circuit diagram. We recommend hand-drawn solar circuit diagrams for like elementary and middle school teams. When they get into the high school level, we're going to show you how you could use PhET. There's also Tinkercad has a circuitry lab, and there's other things like CAD that you can use to do a more professional version of a solar circuit diagram. But know that this is a great resource and it also has all of the symbols that you might need for drawing your diagrams. This is a great reference. The other document that I'm going to be referencing in this video is our solar circuit diagram challenge, where we actually provided solar circuit diagrams and the students had to then build the circuits and show that they worked properly. And in that document, which we can share with you, there is another version of the diagrams that you can use when you're drawing your circuit diagrams. So I will be using these symbols. They're very similar to the ones that KidWind has. All right. So first thing we're going to do is we're going to start with a very basic solar circuit. What I have here are 2 solar panels, and then I have a variety of loads. I have a motor, a buzzer, and an LED light, as well as a switch. So we'll be working through simple circuits. We'll add switches, we'll add multiple loads, and we'll add multiple solar panels. It will progress, and at each stop, we will stop and diagram that circuit before we move to the next one. Okay, so our first circuit we're going to start with is very simple. We're just going to use one of these solar panels and we're going to light the light bulb. Okay, so remembering that the diode needs to be directional. You need to connect the long leg to the positive side of the solar panel. And as you can see, even without the crazy light, we have light. So here is our very first solar circuit. If we were to diagram that, we utilize our circuit diagram key. We indicate a solar panel as power coming in, and then we indicate a light kind of the same way, but with the energy going out. And we have to label the positive and negative side. And all we did was recreated a very simple series circuit. Positive to positive, negative to negative, and that LED went on. So there is your very first simple circuit diagram. And this is it written out in a little bit more digital format. Again, we'll share that with you. Okay, for our second solar circuit diagram, we are still going to use the one solar panel. We're going to switch to the buzzer as our load, but because the buzzer is the most annoying noise in the world, we're going to add a switch. So again, we're going to go positive to positive, negative to negative, but instead of connecting it straight to the negative, we're going to use an extra alligator clip. And you can see that our circuit is broken. We are not generating any, or we're not getting a flow of electrons right now because we have an open circuit. But as we add the switch in, you now have a complete circuit. Okay, so another pretty basic circuit diagram. So for this one, we're gonna keep our solar panel up here. If you remember, that was our solar panel. We're going to add in the buzzer, which is indicated by a box with 2 lines on one side and 1 line on the other. And this positive and negative, and we did connect the positives together, but on the negative side, we added a switch, which is just indicated with a little door. Easy peasy. So that is how you would add a switch into your circuit in terms of your diagram. All right, for the next couple of circuits, we're gonna be using 2 solar panels, which are not gonna fit under my light, so we're just gonna have faith that these circuits work, but we're gonna continue to diagram. So, for the next circuit, we are going to use 2 solar panels, and we are gonna put them in parallel in order to power the motor. Okay, so we have our motor, and we have our 2 solar panels. And so remember, when we put things in parallel, that means that all of the negatives are coming together and all of the positives are coming together. It's a little tricky with these alligator clips to make sure that we get everything and that doesn't move. But we have all of the reds connected. There you go. I don't know if you can see that. We have all the blacks connected, all the reds connected, and then when under enough light, this will spin. Okay, so how do we diagram that? So we need to have now 2 of our solar panels. All right, with power going in, that's our solar panel. We have to indicate our positives and our negatives. Now these 2 are connected together. It's like railroad tracks when we do a parallel circuit. And so now we have to add in our motor, which is super easy, it's just an M circle. And we're connecting again, positive to positive and negative to negative. So that is how you would diagram 2 solar panels in parallel with 1 load being the motor. Okay, now we're gonna step it up to a little bit more complexity. We're gonna go in series now instead of parallel. So we're gonna use 2 solar panels. We're gonna put them in series to power both the light and the buzzer, okay? So again, these are all very directional, so we gotta keep track of our positives and negatives. So we connect the solar panels together, positive to negative, like they're holding hands in a circle, okay? And I like to do this in a big circle so I can literally see it moving around. All right, so we're gonna go the negative side to the negative side of the buzzer, and then this positive side of the buzzer is gonna get connected to the short side of the LED, and then the long side gets connected. And you can see the light comes on already. The buzzer needs a little bit more juice in order for it to buzz, but I promise you that this complete loop would power both the buzzer and the light in series. So to diagram that, you're gonna have your 2 solar panels. Solar panels with your positive and your negative. Okay, so we're in series here. And then you have your 2 loads. There's your negative side and your positive side and your negative side and your positive side. Is that right? Positive, no. Positive side and your negative side of the light. I think that's the symbol for an LED. Did I get that? Or There's two different. That's what the KidWind one does, but we'll use the other one that we've been using with the power going out. Okay, so that's our indicator. All right, so everything's in a big loop. So that's how you would draw two solar panels in series with two loads also in series. I think we're doing good. Okay, so I feel like we've got this. The next thing I want to try is I'm going to show us a diagram of a solar circuit, and we'll see if we can build it together and interpret a solar circuit diagram. For this one, we have this solar circuit diagram. In this one, we have two solar panels, and they are in parallel, and your loads, including a switch, are all in series, okay? So we'll start with the solar panels. Solar panels in parallel is positive to positive and negative to negative. And then we have to have our loads in series, and we have an LED light and a motor. So the motor connected to the LED light. In series. And now we have to have a switch in there somewhere. If we have enough of... Okay. So this is going to go to the negatives. And then this positive side is going to go through the switch. And we're just going to have to figure out how to get all of that connected together. Okay. So in this, we have our two solar panels in parallel, and then all of our loads in series with a switch. So when this gets powered, the idea would be that these two solar panels are going to provide enough power to spin the motor and the light, and then if I open the switch, both of my loads are going to go off. Okay? So this is everything on, everything off. But if we are to be able to build a complex circuit where I can have one load stay on and one load get turned on and off, like having your light on all the time, but I want to switch on and off my buzzer, you know, that is going to be the next circuit that we try. So in that one, we have everything in parallel. So as you can see the train tracks, we've got two solar panels. They're in parallel, but now we have a motor and a buzzer in parallel where the switch is here. So that means that the buzzer can get turned on and off, but the motor will always stay running. So the fan in your living room stays on all the time, but you can turn on and off this annoying buzzer, and it's gonna be great. So we can leave our solar panels in parallel. We have a motor. That is supposed to be in parallel as well without a switch. All right, so that's done. Let's see if we can even... But now we have to build another parallel circuit where we have the buzzer now attached to the switch. And again, we have to go positive to negative. So now we have the positive side on all of this positive and the negative side over here with all of the negatives. And the idea would be that now we have two solar panels in parallel that are providing electricity to the motor at its own circuit. And then in parallel to that, we have the buzzer And then the switch would be able to turn on and off the buzzer because it's in a parallel circuit. Okay. And that is this diagram here. Okay, so we've worked through all the way from simple to complex. We've drawn the circuits as a diagram, and then we've taken diagrams and interpreted them into solar circuits. I'm hoping this helps you feel more comfortable with filling out your solar circuit diagram for this solar competition. Also remember that for those of you in high school, or if you are already working in Tinkercad, there are lots of online programs where you can get to be a little bit more professional looking. So this is PhET. This is a program offered by the University of Colorado, and you can build these circuits. They only have batteries, but you can make the batteries match the voltage of your solar panels if you want, and come down here. So mine's set at 9 volts, but really okay, I'm setting a fire. It doesn't like it when you're at different voltages. So you gotta come back down here and go back down. Mine are both at 5.8. All right, now it's happy. Whew. Okay. I have 2 solar panels in parallel powering a light bulb, but it has a switch. And the cool thing about PhET is you can not only diagram your circuits, but you can also come in here and better understand the current and the voltage. Because they're in parallel, my voltage is still 5.8, but they can be multiplying the current. And so you'll see that on the main line here going to my light bulb, you have 5.58 amps. If I move the voltmeter to one of the batteries, you'll see that it's drawing half of that current because it's sharing the current for the 2 parallel circuits. So it's a neat way to investigate. You can add resistors and things like that. The only load that they have is a light bulb, so you can take with it what you can. But this is a great resource for building your solar circuit diagrams. Again, Tinkercad also has a great version. If you're working in CAD, Autodesktop, any of those, you can totally do your circuit diagrams in that. I actually built all of these in PowerPoint because I'm super old school. Anywhere you can diagram it is great. The judges and the folks at KidWind just want to see that you understand what you did with your circuit and what that means for how much solar you're providing and what your loads are using. If you have any questions, if you need more help, please contact us at case@jmu.edu and we'll be happy to help you in any way we can. Hope this helps. Have a good day.